Okay, so Simpson's rule here, we've got to integrate this here between 0 and pi over 5 of e to the tan squared x using 5 ordinates, right? So if we've got 5 ordinates, then that means we will have one less, so then we'll have 4 strips, okay? If we try to visualize what's sort of going on here, right? In this case, because it's between 0 and pi over 5, this graph essentially will be, we're interested in the area, and we're between 0 and pi over 5, okay? Now it's going to have 4 strips, okay? So what I mean by strips is as follows, okay? 4 strips where the gap between them is sort of meant to be equal, right? 1, 2, 3, 4 strips, and if you notice then 5 ordinates. There's an ordinate there, ordinate there, ordinate there, ordinate there, ordinate there. So this will be your x0, okay? This will be your x1, this will be your x2, this will be your x3, this will be your x4 value. So you've got 5 ordinates, 1, 2, 3, 4, 5, and ultimately 4 strips. Now the first thing you do is, okay, you get your formula booklet and you go to page 7 on it, and you've got the Simpsons rule there, okay? But the first thing you're going to look at here with the Simpsons rule is this bit here, right? You need to work out what your h is, right? Your height, and that's talking about the height between the ordinates here, okay? So we're talking about this here. Now to get h, you use that formula b minus a in the formula booklet over n. So your b is your upper limit, which is pi over 5 from that one up there. Take away then your lower limit, which is 0. And then you divide it by n, which is the number of strips, okay? So of course we had 4 strips here, didn't we? Okay, so pi over 5 take away 0, it's pi over 5. Divide by 4 is pi over 20. Alright? You could even type that into your calculator, okay? If you're not so confident at this. So you've got pi, let's make that into a fraction over 5. Take away 0, okay? And then put that then all over 4, and that comes out to be 1/20th pi, but better to write it as 1 over 20 pi, okay? Or pi over 20, sorry. Now, that is the height. That's the height there between each ordinate, right? So what we'll do now is we'll work out what x0 is, right? Now, x0 is the first ordinate, so we're starting at 0, so that's what x0 is. And then what we'll do then is we'll work out what y0 is, okay? So we will just chuck now what x0 is into this here, okay? E to the tan squared x. So we're going to put that into our calculator. So for the first time, I'll maybe write this down here. E to the tan squared 0, right? That's what x is in this case. So we'll type that into our calculator. Now it's important that your calculator is in radian mode, okay? When you're doing integration, so shift set up there, and then we press radians, which is number 4. Okay, so that's sorted out. We're in radian mode. So to type this in, then I'm going to put E. Okay, where are we? E. No, shift E there, right? And then we're going to put tan. Okay, 0. Right, now I want it to be tan squared, so I need to put a bracket around tan. So if I go back here and put a bracket there, in order for me to square it, right? That's how I would write out my calculator, and then I'd press equals, and it should give me my answer. There you go, I've got 1 there. Okay, so that's equal to 1. Now my next ordinate x1 is going to be 0, and then I'm going to add on that height, okay, which is pi over 20, isn't it? To 0, and 0 plus pi over 20 is just pi over 20. So I'm going to put that in here, okay, y1, so that will be e to the tan squared of pi over 20, okay, and I'll work that out. So I get my calculator, and I'll go back and I'll use this result here, and I'll change this to be pi over 20. Okay, so I press the fraction button there, and I press equals, and I get that out, right? So it's important then to write all of this down. 1.025402923, okay? And we've got that there. You've got to write all of it down, right? x2 then will be another pi over 20 along, okay? So we need to add pi over 20 onto this, right? If you think of this as 0, this is pi over 20. So So you need to add another pi over 20 on. So if you add another pi over 20, you've just got 2 pi's over 20, haven't you? Basically. So then your y2 will be this with 2 pi over 20 in. Okay, I'm not going to write that out again. There's no need to keep writing it. The most important thing is the answer. So I go back here now on this, and I'll chuck in 2 up the top, and I've got then my answer there, 1.111. So I'll write all that in, 1.111, 347,018. Okay, so then I'm going to go for my x3, which is another pi over 20 long. So now I've got 3 pi over 20. So that will be y3, and I'm going to put that in here. So change this now, go back, change this, change that to 3, and I've got 1.29643239. Okay, and then I'm going to do my x4, which will be my last one. If you think about it here, my last one, that will be 4 pi over 20, 4 pi over 20, and of course if you think about it, 4 pi over 20 is just that, isn't it? 4 pi over 20 is pi over 5, isn't it? Because that would simplify. All right. So you've got to the end there. Now I can leave it as 4 pi over 20. There's no harm. Let's go back here, change this then to 4 pi over 20, and I get that at 1 point. Write it all down: 695307338. Okay. So I've got all my y values out. We then go to the formula book, and we use the trapezium rule. Okay, so I'm going to put that here, all right, and you can see then the integral that I want. Okay, so I'm going to call it I for integral. Okay, and that will approximately equal to 1/3. Okay, the height, now we know the height, if we go back up here, was pi over 20, so times pi over 20. Okay, then we've got the squiggly bracket, right, or we can use big square bracket if you want. And then if you notice then you've got y0 plus yn. Now remember, n represents number of strips, okay? So n represents 4 in this case, doesn't it? So y0, which you worked out to be 1, add then y4, which is the last one. So you can have 1.695, blah, blah, blah. Now, I don't need to write it all out when I put it on here. When I type it in my calculator, I need to write it out. But when I put it here, I can just do that, just to save a bit of time. So then, there's my y4 dealt with, and y0, okay? Then if you look then next, you've got 4 then lots of the odd ones, okay? So y1, y3. So the odd ones will be that and that. So plus 4, 1.02, blah, blah, blah. Plus then that's the y1, and then the y3, 1.29, etc., etc. Plus then it says in the formula twice the even ones, okay? So twice the even ones, well, I've just left with that one then, 1.1, 1, and then I close my bracket. So all I've got to do then in my calculator, I need to just work this out, and then I'll get my answer. And what I tend to do is, I tend to work out this bracket first, okay? So on my calculator, I will type in now the 1 plus then the 1.695, which is there, isn't it? So 1.695307338, okay? Plus then the 4 lots of then the 1.02540923, plus then the 1.29 643299, close bracket, plus then twice the 1.11, mistake there, 111347018, okay, and then I missed out a 1 there as well, haven't I? Let's go back and check that. So I worked that out, okay, inside the bracket. So I've done all of that nonsense there inside the bracket there. Now I've got to times it by pi over 20 and times it by a third. Okay? Doesn't matter what order I do it in. That's the way I would sort of do it. Work out the bracket first, then I work out that, and I've got 0.74379012, etc. They want 5 decimal places, 0.74379, and I've got my answer.